All right, let's jump right in. We're going to tackle a question that sounds like something straight out of sci-fi, but it's actually at the heart of how we discover anything, and it's this. How do you even begin to understand something you literally can't see?
Seriously, take a second. Could you perceive a fourth spatial dimension? And I don't mean just, write out the math for it. I mean, see it. Like the way you see the height, width, and depth of whatever room you're in right now. It feels kind of impossible, doesn't it? Well, that's our starting point.
This quote just nails it. It gets right to the heart of the problem. Picture a little 2D guy living on a flat sheet of paper, okay? Now, what happens if you push a 3D sphere through his world? What does he actually see? Well, first a tiny dot appears, right? Then it grows into a line. Then it shrinks back down to a dot, and poof, it's gone. He would never, ever be able to understand the whole sphere. He only sees its shadow passing through, its projection. And guess what? That's basically us, trying to look at a fourth dimension.
So yeah, the first step is just admitting we have limits. It's all about what's going on beyond our senses.
And look, this isn't about you not being imaginative enough. It's actually baked right into our biology. Our brains are literally hardwired for 3 dimensions. Think about it. We evolved to, hunt things, dodge predators, and pick fruit, all in a 3D world. Our whole sensory toolkit, everything, is built for this reality. We just don't have the gear to process an extra spatial dimension.
So, if we can't see it directly, what do? Well, we have to rely on this idea called projection. And a shadow is the absolute perfect way to think about this. Your shadow tells you some stuff, right? It shows your basic shape, how you're moving, but you lose so much information. There's no depth, no color, no texture. A projection is basically an incomplete echo. It's a clue, for sure, but it is never the whole story.
Okay, I know this is all getting a little abstract, so let's bring it back down to earth. We're going to look at a totally different puzzle that, believe it or not, uses the exact same logic to solve it. And here it is, the International Linguistics Challenge. Now, stick with me here. This isn't some random detour. This is the whole key. This puzzle is the perfect analogy for what we're talking about, because it forces you to figure out a hidden, complex system when all you have are a few tiny clues. So put yourself in this spot. You're a linguist, and you've discovered this language X. You have no dictionary, no grammar guide, nothing. All you've got is like 5 or 6 sentences and what they mean in English. That's it. These few sentences are your only projections, your only clues to this huge, invisible system that is an entire language.
So, how do you get from a few random sentences to a full set of rules? Simple. You become a pattern detector.
Okay, check this out. On the left, you've got a physicist staring at the 3D shadow of a 4D tesseract, trying to make sense of it. And on the right, you've got a linguist staring at a few sentences, which are just shadows of an entire language. See the parallel? It's the exact same problem. Both of them are working with incomplete data, with these projections that hint at a much bigger hidden reality.
And this is where the magic happens. Watch. As soon as you organize the data you have for language X, boom, a pattern just jumps right out at you. Look at how the words line up. You've got Kanabi and Lomu in that first column. Those are the ones doing the action, the subjects. Then you have Telem and Pano in the middle, the things having the action done to them, the objects. And the verbs, the action words, they're always at the end.
And just like that, there it is. We did it. Just by looking at our tiny bit of data, we've figured out a core rule of this invisible system. We know that language X is a subject-object-verb language. We didn't need a textbook, we just had to carefully analyze the shadows we were given.
Okay, so what's the big takeaway here? This whole process, it's not just for weird language puzzles or high-level physics. This is the fundamental toolkit for how we humans understand, well, anything.
It doesn't matter if you're a linguist or a physicist, the playbook is exactly the same. Step 1, you isolate the basic building blocks. For language, that's sounds. For physics, it's dimensions. Step 2, you analyze how those blocks combine in the clues you have, how sounds make up sentences, or how dimensions show up in projections. And finally, step 3, from that analysis, you figure out the hidden rules, the grammar of the language, or the laws of physics. And here's a really crucial point. The goal isn't to create a perfect one-to-one copy of reality. I mean, that might be totally impossible. The real goal is to build a model that actually works, a model that can predict what's going to happen. Our little grammar model, it lets us create new sentences in language X and be pretty sure they're correct. A physicist's model of 4D space, it helps them predict what's going to happen inside a particle accelerator. They are incredibly useful working approximations of a reality we can't see directly.
But this brings us to a really profound and maybe even permanent limit to what we can do.
Because there's a world of difference between knowing something and actually experiencing it. Using the toolkit we've been talking about, math, logic, pattern recognition, we can absolutely know things about a fourth dimension, for sure. We can describe it, we can write equations for it, build these amazing models, but we might never ever be able to actually feel it, to experience it with our senses, the way you're experiencing your 3D room right now.
Let's go back to that 2D world, one last time. Imagine a 4D being passing through our 3D space. It would be just like that sphere passing through the paper world. To us, it might just appear out of thin air as a weird little blob. Then it might expand and morph in ways that make no sense, and then just as suddenly shrink and disappear. We wouldn't be seeing the being. We'd just be seeing a slice of it, a bizarre, confusing cross-section. Just a baffling, incomplete projection.
So in the end, we have this absolutely incredible toolkit. It's how we make sense of everything we can't see, how we map out realities that are beyond our senses. We use it for everything, from decoding ancient languages to figuring out the fundamental rules of the universe. And that really leaves us with one last huge question to chew on. If this is how we understand the world, by decoding the shadows of hidden systems, then what other realities are out there, right now, just waiting for us to find their pattern?